Hello and welcome, my name is Nilaus and this is the third installment of our tutorial of Angel's Petrochemicals. We are about to head into the most difficult part of, I think, the entire mod pack, the organic chemistry that leads into plastic. So sit back, relax and be taken on a journey to the wondrous worlds of organic chemistry and plastic. Can't believe I'm saying that. I'm actually creating a YouTube tutorial on organic chemistry, though hidden in the form of a game, but nevertheless still quite strange. Now, if we go back to our previous episode, we would see that where we focus on residual gas and synthesis gas, we are actually seeing that this was where we ended up with a process that takes synthesis gas in and it creates a synthesis gas catalytic methanation, methane gas, ethane gas, and butane gas. I did not explain what it was used for, but nonetheless, here it is. Need some more. Let's take all of these. Let's take them by type, and it is actually possible to do the same thing with a much simpler process. Here we have the natural gas liquids. If you recall, when we were back to the very first episode, the basic oil and gas, this was actually the main output of the gas branch of that process. I said this is going to be used later on towards plastic, and that's exactly where we are now. So we take all of our natural gas liquids, and that's where we go in. We go into a process that in here is called gas fractioning, but as far as I can recall, it's actually called gas fractionation. It takes the natural gas liquids and it fractions it into methane gas, ethane gas, butane gas, propane, and pentane. But in this case, it's only the three first of them that are in. In any case, we can also see here, this is quite an efficient process if it does not jam. Why is it jamming? It is jamming because it's not able to put them back in there. So let's have a look at how they're working. Yes, they're working, and over here the usual habit of putting them back in. I very strongly recommend building a setup like this, especially if you're running a heavy robotized setup. Not like 3, but as many as you like. But the fact that you transport with robots, you transport them around using the robots, and the robots, they are making sure that they go around here and everything is in barrels. So put it back into barrels. Yes, there's a large steel investment, but so be it. So you can see these are just cracking away, literally, or fractioning away. Now we have ethane, methane, and butane. And now the question is, what are we going to do with that? So those are the ones I've set up here. Here we have butane. Let's put in our butane in here. Here we have ethane. Let's put our ethane in. And here we have methane. Let's put our methane in. Now these ones will be activated. They are running a very, very similar process. So we'll just activate all of them at once and then walk through them. All this process takes the methane in, goes into a chemical plant, adds some purified water. We get the purified water from up here. Goes in here, and it then enriches the methane, becomes methanol gas, and then there is 20% residual gas output. Again, we take it in here, goes out, the residual gas goes up, gets consolidated, and put in here. Now the other part, the methanol gas, is being put back into barrels, and that will be ready for the next year of process. The next one, we have the ethane. Ethane, it becomes ethylene. Yes, and again, the same is we take 6 ethane in, 6 purified water, it becomes 8 ethylene gas and 2 residual gas. Again, the residual gas goes up here, becomes residual gas. This goes back into the process that I described in the second installment of the tutorial, where the residual gas becomes synthesis gas, and then we go back to the very first process here that I showed, where it can then go into the feeding into again. Again, it's extremely easy if you set up robots for it. Well, extremely easy, maybe a bit overstating it, but it is quite manageable when you have robots doing it. Without robots, with trains like I'm currently doing, it's a lot more management, but definitely doable nonetheless. So now the last one, we should also go through this one. We have the butane that goes in, still exactly the same formula. Butane, 6 butane in, 6 purified water in, and then we have benzene gas coming out. So now the output of this tier is methanol gas, it is ethylene, and it's benzene. Again, nowhere near plastic, but nonetheless we are approaching it. Now we go into the next tier, and this is where we add another component. In the beginning, in the very first tutorial, I stated that the three, let's have a look at it, the three original components of the fractioning, or no fractioning, the oil refining. So this is the one I'm using, the oil and condensate refining, where I get mineral oil, fuel oil, and naphtha. I stated that in my opinion the naphtha is slightly more valuable than the base mineral oil and the fuel oil. The fuel oil and base mineral oil have some other uses, like base mineral oil has the lubricant, fuel oil, well, not really. But the naphtha, it has one additional purpose that's very valuable. This is what we see here. Here we have a process. Let's start it up, kick it off. We have naphtha coming in, we have purified water coming in, and what happens is that these go in again to a steam cracker. In this case, it needs a red catalyst here. The red catalyst is the easiest catalyst. So just set it up like this, you request a chest, that kind of thing, keep it going. And here we have, now we're creating propene. There is another way to create propene that we'll just highlight. And that is, let's see, propene. Propene, it has two ways. Either the one we say by naphtha, or this one from methanol gas. I have been using this one as well, but in actual fact, it's much simpler to do this because the methanol gas comes from methane. The methane comes from the gas fraction, which could come from synthesis gas, which could again come from naphtha. So there's a lot of steps on the path that are not efficient. Instead, going straight from naphtha to propene is very efficient and very rewarding. So I recommend not using the methanol for this part because the methanol has a different purpose. This one is now creating propane. Not a lot of it, but some. We just lead this going. So that's one of the next tiers. This is we are almost getting there. We are getting there, almost there. Now the next one is where we have the ethylene. The ethylene comes in, and this needs the blue. Oh, there's actually a little bit of error here. There we go. So it goes in, it needs the blue circuit, blue catalyst. The blue catalyst is the most expensive one. Nonetheless, it goes in here. Very simple process, much simpler than the other one. It just basically gets, let's take a look at it here, 10 ethylene in and 5 polyethylene out. So it is having the output. Nonetheless, it is called poly, so you would expect that there is something more to it. They are again being put in here, the polyethylene, and that is another ingredient for the later stages. Again, more advanced organic chemistry than anyone really cared about. And again, this one, I did some copy pasting of blueprints, and I guess that one, the last line was missing. Now here we will also enable this one. This is now our benzene, also coming from the previous, and the benzene is going in. The benzene is a bit strange here because the benzene requires, if you look at this one, it requires the yellow catalyst. Yellow catalyst? Okay, it's because it's over there. So it's only where it's the first. Anyway, the yellow catalyst requires tungsten, which is very difficult to get, and nickel, which you have tons and tons of because it's not used for anything, at least the way I play it. In any case, here we have, and it's worth noting that, for example, the oxygen gas, you need 10 oxygen gas. And oxygen gas, there are basically two ways of getting it from. Oxygen gas comes from two ways. You can either do electrolysis of water, which requires a hell of a lot of purified water. Alternatively, you can do it from air separation, nitrogen gas and oxygen gas, from the compressed air. The problem is the compressed air generators here, they are really slow, so you need 8. And even 8 is not really enough to keep just 3 of these fed. It's quite ridiculous how slow it is, so it is really up to the individual whether you would want to do it one way or the other way. This will generate phenol gas. Okay, so that's again one more. Now the next one we have up here, actually the last one, we have the methanol gas. This is the reason why I didn't want to use methanol gas to make propene, because then I don't have it for this process, which must use use methanol. The methanol goes in here. The methanol uses the green catalyst. The green catalyst is a bauxite and silver ore, the aluminium ore. And again, you have, what is it? It is 10 in, 10 out. It basically transformed methanol gas into formaldehyde. So now at the end of all of this, when all is said and done, we have formaldehyde. Let's pick up what we have. You know what? I'll come back to this. This is going to be the last one. I'll pick up. I'll go down here, go to the bottom one, and then we'll take them one by one. So that's the polyethylene. Over here we have the propene. Now let's take the propene and move on to the next step. Let's try to put in the propene here and see what happens. So this is finally where we get it. This is the first tier of plastic production. It's very, very simple. It just says, put propene in, you get plastic out. It goes 4 propene gives 1 plastic bar. So you need quite a bit of propene coming in. However, this is the best way. If we go back, this is the best utilization of your NAFTA. NAFTA, make it into propene, make it into plastic. That's very, very efficient. Well, yeah, I don't know if it's efficient, but it's actually, it's easy. That's what it is. Now the next part here, the polyethylene. Now let's grab all the polyethylene that we have created, get the last 2 with us, put them in here together with some NAFTA, so don't use all of it for that process. And now let's look at what the process is. This is plastic 2. This is a much more efficient plastic. You take 2 NAFTA, easy, 2 polyethylene, well, that is still some, but in this case you're creating 2 plastic, and it's fast. It's really fast. So once you have this up and running, you're going to be very happy with plastic. But it doesn't end there. We remember we also had the last 2 where we got the benzene in. The benzene became the phenol, and the methanol became the formaldehyde. Now we take those 2, methanol and formaldehyde, put them in here, methyl and formaldehyde, and that generates now again into an advanced plant, and that will generate plastic 3, which takes 2 formaldehyde and 2 phenol gas, and that generates 3 plastic in this case. So this one is really the money maker. And you can see here it is a long process to get all this done, but it's not actually that difficult. There are some paths here, so keep this in mind. This is the propene. The propene comes from NAFTA. This will be the first one you make. It doesn't require anything except, let's go closer. It just requires NAFTA and water, because then you can make propene. It doesn't, this is a catalyst 2 or reverse catalyst, which is easy, and then you have the plastic going. Now the next one, the second one is polyethylene. You get that from the ethylene here and the blues. The blue catalyst, yeah, they're difficult to make, but they don't use very much material, so you just need a tiny bit coming. And this is where you can go back to one of my refining tutorials, because that contains some tricks on how to get slag into these. And you can see here that comes with the ethylene. The ethylene, we're just tracing it back. The ethylene is the middle one. Ethylene comes here, and again the ethylene is a straight line back from the ethane, which is one of the 3 components. Now let's take it from here. Those are the 3 components. The methane, so now we have the NAFTA version that goes into propane, that goes into plastic. We have the ethane that goes into ethylene, that goes into polyethylene, goes into plastic 2. And now the last one, it's the methane and the butane. The methane and butane. Here we have the butane. Butane becomes benzene, simple process. Methane becomes methanol. Yes, those 2, that one, they are now being linked up to here. This is where we have benzene becomes phenol, and methanol becomes formaldehyde. And those will now then be recombined into plastic 3. You can see how efficient this plastic 3 is. I wasn't even using very much, and it's just cranking away as fast as it can. And it is a very efficient method here. So we have 1,000 there, we have about 800, 500. So even though this one started first, and it's vastly overtaken by the plastic 3, and it just keeps going. It uses so little materials. So even though each of these, the formaldehyde and the funnel seem really daunting to get into, then it's really not that bad, because once you get it, it just doesn't use very much. So we can go back here, grab some of that, and put it back in. And then it keeps going. But of course, with robots, it'll be extremely easy to feed these in and out. And I strongly recommend building modules like this, because you can just say, all right, in this case, I want 5 of these, I want 10 of these, or whatever you want. But they will be transported back and forth with robots. Very, very easy. So that will actually, I think that was a pretty clean walkthrough of of the most complicated part of Angel's model, the organic chemistry into plastic. So I hope you've learned something from it. The recap is very short. There are 3 types of plastic. One, the propene base, comes from NAFTA, very easy to make, very early game. The polyethylene is a bit more efficient, comes from ethane and ethylene. And the last one, that's the most complicated one, comes from methane and butane. That's more complicated, but it's a lot more efficient. So once they are set up, you're basically using every single resource that comes out of the gas and oil wells, and it just generates tons and tons of beautiful plastic that is going to be used almost everywhere in the base. So I hope this was useful. This is one thing that I've been struggling with for a long time, and I think I got it now. And I hope this has helped you as well on your journey. So if you like it, please leave a like and a comment in the section below, and hopefully tune into another one of my tutorials, because this is not the end of it. So thank you for joining, and see you next time. Bye.